A warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we will be discussing about important concepts of multicollinearity, linearity, and homoscedasticity in SPSS. So what do these three terms mean? They are very important for progressing with the regression analysis. That means in case you want to do a regression, you need to check these assumptions. They are the preconditions for performing regression analysis. So, in case of a simple linear regression, wherein you have one independent variable and one dependent variable, we call it a linear regression, a simple linear regression. In case we have more than one independent variable, we call it a multiple linear regression. In case we have more than one dependent variable, then we move over to structural equation modeling, wherein we can analyze complex cases. That is why we would require the help of IBM SPSS AMOS. So then we will be working on AMOS. But for simple linear regression or for multiple linear regression, you can always trust SPSS. So today I am going to show you how to assess the multicollinearity, linearity and homoscedasticity of the variables in SPSS. So first of all, we will try to understand what do these three terms mean. Multicollinearity represents high correlation which is more than 0.7. This is the correlation coefficient denoted by R amongst two or more independent variables in a regression model. This leads to unstable coefficient estimates, inflated standard errors, and difficulty in determining individual impact of each independent variable on the dependent variable. Linearity. It defines the relation between IV and DV, which has to be a straight line. It could be a positive relation or a negative relation. Homoscedasticity. So in case the error terms, which are also known as residuals, I will be explaining to you what are residuals and how do we calculate the residuals. In case the residuals have consistent values across all values of IV, that is independent variable, then we say that the data exhibits homoscedasticity. Whereas heteroscedasticity leads to unreliable standard errors, unreliable t-values, unreliable p-values, and unreliable hypothesis testing. Conclusively, we can say that heteroscedasticity leads to type 1 and type 2 errors. I have previously discussed in my videos what are type 1 and type 2 errors. If you would like, you can go back to the playlist and check those out. So now let us go to the SPSS and do the real analysis and learn how to assess multicollinearity, linearity and homoscedasticity. Here we are back again on the same data which we are using for analysis. Last time we learnt about how to identify unengaged responses through standard deviation, and I told you that if any of the cases, any of the respondents exhibits a standard deviation of lesser than 0.25, then it is deemed to be unengaged response and we must remove it. So these are the cases. I have arranged standard deviation in descending order, you can see here, and these are the cases which have value of standard deviation below 0.25. So I need to remove them out, clear them out from my data. So the total data count which I have is 150. I'll remove these by selecting them like this. and remove them, clear them out of our analysis because we don't want to go further with these unengaged responses. So first we will be testing multicollinearity. How to test that? Go to analyze, regression, linear, and here we'll enter our dependent variable, which is the behavioral intention, mean of behavioral intention. I told you how to calculate mean of behavioral intention by the transform function, computing the variable through the indicators of BI in the previous videos. So I put it in dependent, and my independent variables, mean of food quality, mean of cultural authenticity, mean of service quality, and mean of value for money in independent. So here in statistics, we will check collinearity diagnostics. This will give us the multicollinearity assessment through the tolerance and VIF values. I click on continue. I do not need to check any of these. Let us see. Do not need to change anything. Here also nothing has to be changed. Don't change anything. This is just for your reference. I am showing you that we do not need to change anything, except we need to click on collinearity diagnostics in the statistics tab. Click continue, press OK. So now we'll be getting collinearity diagnostics. You see here coefficients, tolerance and VIF values, variance inflation factor. So here you see the VIF values, the recommended VIF values, the threshold values say that it could be up to 10. Some strict thresholds say it could be up to 5. But mostly it is recommended that if the VIF values are up to 3, then your data is quite good and it does not exhibit multicollinearity issues. So here we have 1.13, 1.47, 1.50, 1.08. We are good to go. In tolerance, we say that the value has to be more than 0.1. Again, you have 0.9, 0.6, 0.6, 0.8. So we have good tolerance value. So now we can go ahead. We do not have any multicollinearity issues in our data. So now we talk about the second assumption of regression, which is checking the linearity. Linearity means the relation between independent variable and the dependent variable has to be a straight line depicting a a directly proportional correlation between the independent and the dependent variable. We need to test it for all of our 4 latent variables, which is food quality, cultural authenticity, SQ service quality, and VM value for money. And BI is our dependent variable. How to do that? Just go to analyze, compare means, and here I have my dependent variable, behavioral intention, and this is all the 4 variables. I need to check them one by one, so no need to perform it 4 times for 4 independent variables. I put them all together over here and I'll get 4 different results for the assessment of linearity of these 4 independent variables with the dependent variable. So in the options, I just check test for linearity. It has to be clicked and press continue and press OK. Now let us see. We go to this ANOVA table. It will give us the linearity test between the dependent variable BI and independent variable food quality. Linearity. Now you see the significance value. Is the linearity significant? Yes, it is significant because the value is below 0.05. For BI and CA, again linearity is significant, and the deviation from linearity is non-significant. It is greater than 0.05. It is 0.322. For service quality and BI, linearity is again significant. It is lesser than 0.05. Deviation is non-significant. You see here 0.163. That means deviation is non-significant. The fourth is value for money. Again, we have a significant linearity and the deviation from linearity is non-significant. So this is how we test linearity. So now we go to test for the third assumption for regression, which is homoscedasticity in the data, which means that the error terms have a consistent variance across all values of independent variable. How to test that? Again, we'll go to analyze, regression, linear, and here we have the independent variables and the dependent variable. We go to plots, and in the plots, what I need to do? I need to put the standardized value of residuals in the y-axis, standardized value of the residuals in the y-axis, and predicted standardized value in the x-axis, like this. So what is a residual? Residual is an error which we get through subtracting the predicted value from the observed value. Okay, so whatever observation you have gathered, the data which you have gathered, the value which you have got through that, we have to subtract the predicted value from that observed value to get the residual. So now we are trying to build up a plot wherein the x-axis will represent the standardized predicted value and y-axis will represent the standardized residual value. Herein we click histogram and normal probability plot and click on continue. Press OK. So now what do you get? You get this scatter plot and the values here. So you see here. So this seems to be quite like a normal curve, a bell-shaped curve. This is the normality plot. This is the histogram, right? Now, PP plot, you see here, most of the points should lie on this straight line. They should not deviate much from this straight line. And then we have this behavioral intention as the dependent variable and regression standardized predicted value on the x-axis, regression standardized residual value on the y-axis. Now, these dots should depict a rectangular kind of a pattern. They should be building up a rectangular kind of a pattern to signify homoscedasticity, and they should be ranging from -3 to +3. So if I see here, this is somewhere close to -3 and this is somewhere close to +3. So this shows that all of my data points lie within the range of all of my, this shows that the points, the dots lie between -3 to +3, which satisfies my condition of homoscedasticity. I hope the video was quite useful for you. See you next time when we will be testing the multivariate normality, which cannot be performed in SPSS, and we need to go into AMOS, build a measurement model, because now all the preliminary tests, scanning and screening of data has been performed, outliers have been checked, multicollinearity has been checked, linearity has been checked, homoscedasticity has been checked. Now we are ready to go ahead for the actual regression analysis in structural equation modeling, which I'll be showing you on AMOS